Hi everybody, this is the lesson on u-substitution integration, and it basically is because we do not have any antiderivative or integration rules for something like the chain rule right here or something like the product or quotient. So what we do is we do this substitution to turn around and make it into an integration that we could do the power up rule and the different rules that we already know. So the question is, what do we use for the u? And what you're going to look for is when there is something like under a root, an expression under a root, or being raised to a power, or possibly in a denominator, an exponent of e, or a natural log. And again, you guys, these are situations that we'd normally look at kind of as an opposite of a chain rule, but we don't have that ability. So we are doing a substitution, and we'll go from there. So the first thing we want to do is take a look here how within those parentheses is to the power of 6. Now that looks like something we would have had to do a chain rule to get back to our function. But again, we are going to be doing a u-sub, and what we have is identifying that expression. So for this one, our u is going to be 4x squared plus 8. So what we want to do is take the derivative of that. Now we have that u, so we're going to have du as the derivative, 8x, and we're going to have that dx. We have, take a look in this integration problem. We have a dx right there. And what we want to do is substitute for that as well as the expression. So now what we need to do is to solve for the dx. And we have, from that differentiation up above, we have du is equal to 8x dx. We want to isolate the dx. We want to solve for that. That's all being multiplied, so we're going to divide. So our dx is equal to du over 8x. So now we're going to make the substitution and then turn around and do our integration and then substitute that u expression back into there. So we'll go on to the next examples. And again, we need to identify the u. And again, it's going to be something that looks like we would have had some chain rule something happening. So in this case, it's going to be that 3x to the 4th plus 10. We're going to take the derivative of that, and we get 12x cubed dx. Now remember, the plus 10 goes to 0, so we don't have that. All right, so we differentiated that. The next thing we want to do is solve for that dx. So this is where we are isolating it by dividing, and that goes away. So we end up with dx is equal to du over 12x cubed. So now we're going to make those substitutions with the u as well as the dx, and we will end up doing this. So we have our original was x cubed, and this is where we have the u to the 1/2, because that was the square root, and our dx is replaced with the du over 12x cubed. Now here's exactly what we want to have happen. The x cubes go to 1, and we are left with, I'm going to put the 1/12 in front, u to the 1/2 du. Now we know how to do this with the power up rule. So we would have adding our 1, dividing by the 1/2 plus 1. So we would have 1/12 u to the 3/2 over 3/2. And the way this simplifies between the 1/12 and the 3 over 2, oh, let's don't forget our plus c. That would end up going to flipping and multiplying. We would have, let's just write this over here. We would have 1/18 u to the 3/2 plus c. Now, one last step to do. And you see the u right there? We are going to replace that with the original expression for u, which was the 3x to the 4th plus the 10 over 18. And don't forget, that's being raised to the 3/2 plus c. So that would be the integration to get our function. All right, now we're moving on to the other examples, just a couple more. And what you need to look at for this one, if you notice, this is a cubed root. So we have to remember that we're going to be raising something to the 1/3. So taking a look at what's under the cubed root, we have our u is equal to that 2x to the 5 plus 6. We're going to take the derivative of that, and we get 10x to the 4th dx, and remember the 6 goes to 0. So now we want to isolate the dx, because we're going to be doing that substitution. So we are dividing both sides by the 10x to the 4th. That goes to 1. We're left with dx equal to here. So again, now we're going to be doing some substitution back in terms of u, and then get our x variables to go to 1, and we will be able to integrate something. Now, let's just make sure we realize, I want to make sure you guys realize this. This dx is what is going to be replaced right there. So what I have is the integration of x to the 4th, and this is going to be my u, right? That 2x to the 5th plus 6, that is my expression I am using, and that radical is 1/3, and our dx is du over 10x to the 4th. So again, this right here goes where the dx was. So now, here's what we wanted to have happen. The x to the 4ths go to 1. And we are left with, I'm going to go ahead and write that constant in front. And now we're doing the power up rule from here. So our function is, if I do the power up rule from that, what do I have? 4/3. So I have, let's just write this here, 4/3. And then when I flip it and multiply, I'm going to have 3 over 40 u to the 4/3 plus c. And the last step we have to do is to replace that u with the original expression that we had for u. And that was the 2x to the 5th plus 6. And its power is 4/3 plus c. And that is that function. All right, on to the next one. I think we just have this one to do. And what we have in this case is our e raised to an expression that looks like, right, that it might have to do with a chain rule. But again, we only are able to do the u-sub. We do not have any integration rules for something that could have potentially been a chain rule. So in this case, my u is going to be the x to the 4th. Take the derivative of that for x cubed dx. Isolate the dx, and which means our dx isolated is this du over 4x cubed. And again, that's what's being replaced right there. Because again, we want to try to have everything's in terms of u so that we can turn around and do an integration we are capable of doing. So now when I'm substituting back in, I'm going to have the 5x cubed e. Our substitution, our expression for u is at x to the 4th. My dx is du over 4x cubed. Now this is exactly what we want to have happen. Those x cubes go to 1, and we are left with 5/4 e to the u du. Now we can take the integration of this. If you recall, let's take a look there. Let's do our capital F of x. And again, our antiderivative of e to the u is just e to the u plus c. And we have the u. We're going to want to replace that with the original expression of x to the 4th. So we would have our function is 5 fourths e x to the 4th plus c. All right. Please let me know if you have any questions. Have a good day, you guys. We'll see you next time.